Hello everyone, I am Sravani, belongs to the Department of IT, second BTech. I am here to discuss about travel salesman problem using branch and bound. Firstly, we can see what is travel salesman problem. Travel salesman problem is an algorithmic problem tasked with finding the shortest route between a set of points and locations that must be visited. Here I am solving the travel salesman problem using branch and bound by using the method of least cost search. Least cost search chooses one of the branch and is going to search in that particular branch by considering the least bound and the upper bound. Here I am considering the cost matrix like this. In this cost matrix, we have to do row reduction. That is, for every row, we can check the least element. First row least element is 1, second row least element is 2, third row least element is 4, fourth row least element is 4, fifth row least element is 1. By all adding this we can get 12. After doing the row reduction, the matrix is like to be this: 2 minus 1, 1, 5 minus 1, 4, 7 minus 1, 6, 1 minus 1, 0. After doing that we can do column reduction. How we can do the column reduction? Let's see. For every column we can check the least element. For first column the least element is 0, second column least element is 0, for third column least element is 1, for fourth column least element is 0, for fifth column least element is 0. After doing the column reduction, the matrix is to be like this. After doing the row reduction and cost reduction, we should do the cost matrix. How we can find the cost matrix? Here we can add the row reduction plus column reduction. 12 plus 1 equals to 13. Here I am considering the root node as A. From A, where and where we can move either A to B or A to C or A to D or A to A. The cost matrix of A is 13. Firstly, I am considering to move from A to B. That is, from which node to move. From which node from move. That row to which node, that column must be infinite. That is, A row, B column must be infinite. A row, B column and B to A value must be infinite. After that we can do the row reduction. After doing the row reduction, the matrix is to be like this. After doing row reduction we can find the column reduction matrix. Here we can't do the column reduction. Why? For every column the least element is to be 0. After that we can get the formula of C of A comma B plus R cap. R is called cost matrix. Let's check the value of C of A to B. C of A to B. Here C of A to B is 1. 1 plus cost matrix, the value having 13. R cap, that is row reduction and cost reduction of this particular matrix. Here we can get 1. By adding this we can get 15. After that we can check A to C and A to D and A to E. Let's check for A to C. That is, A row, C column and C to A value must be infinite. The remaining values are same as for the previous matrix. After that we can check for the row reduction. For every row the least element is 0. And after that we can check for column reduction. For every column the least element is 0. After that we can find the cost. How we can find? C of A comma C plus R cap. What is the value of C of A to C? 4. C of A to C value is 3. 3 plus 13 plus 0 equals to 16. After that we can find A to D. How we can? Here A row, D column must be infinite. That is, A row, E column and D to A value must be infinite. Remaining values are same as for the previous matrix. After doing the row reduction, the matrix is to be like this. Here we can find the value of C of A comma D from the previous matrix. The value is 3. 6 plus 13 plus 3, that equals to 22. After that we can find the value of A to E. How? A row, E column must be infinite and E to A value must be infinite. The remaining values are same. After that we can do row reduction. Here the least element of every row is to be 0. Hence we can't do row reduction. After that we can check for column reduction. For first column the least element is 0. Second column least element is 0. Third column least element is 0. And fourth and fifth column least elements are 0 respectively. After that we can do the column reduction. The matrix is to be like this. After that we can check the values of a to b, a to c, a to d and a to e. After that which node is consisting the least cost, that must be considered. Here I am checking a to b, a to c, a to d and a to e. After that we can here a to b having the least cost. Hence I am selecting the way from a to b. From B, which nodes are to be visited? Either B to C, B to D or B to E. Firstly, we can check for B to C. That is B row and C column. I am moving from B. Hence that row must be infinite. I am moving to C. Hence that column must be infinite. And the value of C to B, that must be infinite. The remaining values are same from the previous matrix A to B. Why I am considering the matrix A to B is I am selecting the least cost method. That's why I am considering A to B matrix. After that we can check for the row reduction. For every row the least element is 0. Hence we can't do the row reduction matrix. After that we can check for column reduction. For first column least element is 0. For second column least element is 0. Third and fourth columns least elements are 0. Fifth column least element is 3. By adding this we can get 3. After doing the column reduction, the matrix is to be like this. Here I am considering the value of C of B to C as 0. I am considering this matrix. Here I am getting the value of C of B to C as 0. And here I am considering the cost as 15. Why I am considering this 15? In the previous matrix I am considering the cost matrix as 13. But in this I am considering 15 because we are moving from B. That's why I am considering the B cost 15 plus 3, that equals to 18. After that we can move from B to D. That is B row, D column and B to D value must be infinite. B row, D column and D to B value must be infinite. The remaining values are same. After that we can check for the row reduction. Here first and second row the least elements are 0. For third row least element is 3. Fourth and fifth rows least elements are 0. After doing the row reduction, the matrix is to be like this. After that we can check for column reduction. For every column the least element is to be 0. Hence we can't do the column reduction. The value of C of B to D from the previous matrix we can get the value of 6. Cost matrix having 15 plus row reduction, column reduction value have been 13. By adding this we can get 24. After that we can move from B to E. That is B row, E column and E to B value must be infinite. Remaining all values are same. In this matrix we can check for row reduction and column reduction. Here we can do the row reduction and column reduction. Why? Because for every row and every column the least element is 0. I am checking for the value of C of B to E. The value is 0. And the cost matrix of B is 15. And row reduction, column reduction, R cap value is 0. That equals to 15. Here I am moving from A to B. And B to I am moving from E. Why? Because by comparing E with both C and D, E contains least cost. And here I am where to move from E? Either E to C or E to D. Firstly I am checking for E to C. That is E row, C column and C to E value must be infinite. That is E row, C column and C to E value must be infinite. The remaining values is same from the previous matrix. That is B to E matrix I am considering. Why? Because it contains the least cost. After that we can check for the row reduction. For first and 1, 2, 3 rows, the least elements are 0. For fourth row, least element is 7. After doing the row reduction, the matrix is to be like this. From the previous matrix, the value C of E to C we can get 0. And C of A, why I am considering C of E? I am moving from E. That's why I am considering the cost of E, that is 15. Plus R cap value is 7. Because why I am considering 7? Here we can get the value of 7 by adding the row reduction and column reduction. After by adding these, we can get 22. After that, we can move from E to D, that is E row, D column and D to E value must be infinite. E row, D column and D to E value must be infinite. Remaining values are same. After that we can check for row reduction. For 1, 2 rows, the least element is 0. For third row, least element is 4. For fourth and fifth rows, least elements are 0. After by adding these, we can get 4. After doing the row reduction, the matrix is to be like this. After that, we can check for column reduction. Column reductions of all columns are 0. From the previous matrix, we can get the value of C of E to D as 7 plus cost of E equals to 15 plus row reduction value R cap equals to 4. By adding this, we can get 26. After that, we can check where and where to move. I am moving from E to C. Why I am considering E to C? Because it contains the least cost whether compared to the E to D. After C, where and where to move, I am moving from C to D. Let's check the cost of D. That is C to D. That is 0, D column and D to C value must be infinite. After that, we can check for row reduction and column reduction. Here we can't do the row reduction and column reduction. Why we can't do? Because for every row and every column, the value must be 0. Hence, the value of C to D is 0 by considering the previous matrix. Cost of C. Why I am considering the cost of C? Because I am moving from C. That's why I am considering the C cost, that is 22. Plus here the R cap value is 0. By adding R cap value is 0. By adding this we can get 22. This is the final graph. From A to B we can move. B to E, E to C, C to D. The D cost must be 22. Thank you.